Okay, so let's get the slides up here. I'll start early on because there might be some things that I might want to review or things that you didn't or that we didn't cover in the um, midterm. Um, all right. So I probably won't ask you a question on how do humans solve problems. I think that's been killed at this point. Um, let's see. You should know what variables are. Well, that's the people working in my basement, by the way, if you hear if you hear drilling and stuff. All right. So I don't know, outside chance you should know what the difference is between a compiled and an interpreted language, especially since we transitioned from an interpreted language like Python to a compiled language like Java after midterm. Um, Probably not something I would test you on there. Not, not, not. Maybe something related to this slide. Well, it's loosely related to this slide, but from a Java perspective, you should know what system.in and system.out are. We've used system.in with a scanner class, so system.in effectively is the default input stream from the keyboard, and system.out is the default output stream to the monitor. Not 100% sure I'll ask you for either of those, but those should be two things that you're familiar with. Um, we have not done network stuff. We'll do that next semester, but for instance, you can use the scanner to read in from different input streams. We might create a multi-user type program early on next semester where we're using network sockets and stuff. So instead of reading in from system.in, which would always be the keyboard sitting at the computer, like right now, our game is a single user game. And so we are just assuming that we're the only one playing the game. So anything we're reading in from the user is happening from the physical keyboard that's sitting here. Well, what if we had 10 users all connected to our game at once? Um, we would set up a server type thing, which we'll do next semester. We'll start off talking about kind of the client server model. And when those 10 people connect to our game, what we would do is we would spin a thread up for each of those connected users. And the way we would read in input from them, like, I want to go to the north or I want to go to the west, will be through using a scanner, but using the input stream associated with the network socket that that particular user is connected on, rather than the local keyboard. So we'll talk about that more next semester, but for here, just know that system.in means the keyboard on the computer that the program is running on. Not positive I'll ask you about that, but I would call that a possibility. Definitely at least one number conversion problem, probably two. So you should be able to do things like convert from octal to hexadecimal, for example, or binary to decimal, that kind of stuff. Along those same lines, there you should also be able to convert between um, sizes. So you should be able to convert between gigabytes to bits, for example, or megabytes to kilobytes. So somewhere in here, we're going to have that chart, the two table, to go from a bit to a byte is a multiple of eight. And then to go up and down each side is a multiple of 1024. So be able to do those two types of conversions. As computer scientists, we should be able to know the difference between a gigabit and a gigabyte and all that jazz. Will slide 12 be on the final? Let's see what is on slide 12. Um, no, I'm not going to ask you. This dealt with the Linux Hello World program. You'll look at stuff like that closer in the computer organization class next semester. So I'm not going to test you on that. So I'm primarily only interested in, let's say for the final, the Java world view of how do I read in from the keyboard and, what's the keyboard called? System.in. What's the monitor called? System.out. That's all that's in our world when we're doing input output right now. We'll also look at file I/O early next semester because we'll be representing our dungeon as a JSON file and storing that somewhere and then reading that in. We may also look at storing it in a database, but we'll have to see where we're at on time before we start on our um, on Unity for our game engine stuff and starting to put graphics into our dungeon. All right. So two number conversion problems, expect those. So definitely study these kind of slides here. Decimal to binary, binary to decimal, decimal to hex. So these are all the straight line ones, but then we had ones that were going from like, binary to hexadecimal or octal to binary, things that didn't stop at decimal in between. So maybe review those shortcuts. If I tell you to go from binary to hex, there's a shortcut where you don't need to go from binary to decimal first and then decimal to hex. You'll get the same answer, but it's a little bit shorter path. All right. I probably won't ask you anything about ASCII and Unicode at this point. I won't ask you about I won't ask you about this specifically at this point. We're strongly in the object-oriented world right now. Um, yeah, I probably won't ask you about the Java virtual machine, somewhat unimportant. You should know about the primitive data types. I would say specifically, you should know the difference between a primitive data type and an object data type. You don't have to memorize things like, even though I ask it relatively often, I would expect that every single one of you should know that an int is 32 bits um, in most programming languages, but I'm not going to ask you that on the test. But you should know that this list of things, like ints and chars and doubles, these guys are what are considered primitive types in our programming languages, and all they know how to do is hold a value, as opposed to our object types, which we've worked with since the midterm. We've created a bunch of objects like players and rooms and things like that, and they hold values. So, for example, a room knows about the player that's in it, so it knows about that as the one of its fields. But rooms can also do other things like display themselves and have a player added to it and remove a player from it and add exits to it and that kind of stuff. So objects can do a whole lot more than primitive types, but they all can hold a value. But that's all that primitive types can do is hold a value. All right. I won't ask you about memory management stuff. I probably won't ask you about resolution things, but we were learning about how those floats, for example, were 32 bits followed by 16 bits, that kind of stuff. I won't ask you about that on the test. Let's see. I won't ask you about storing negative numbers. You'll learn about that with two's complement in the next in your computer organization course. Won't ask you about Y2K bugs. Um, so slide what 30, what is this, 36? Slide 36 here is our good example of that shortcut going from hex to binary. So you might want to review that. Now, this could be kind of a fair game question. I said that there would be like a conversion problem going from a number of like maybe converting gigabytes to bits or something like that. That could come in the form of something like this. If you have 32 gigabytes of RAM, how many 32-bit integers would fit into 32 gigabytes of RAM? Um, so 32 gigabytes of RAM, you would first convert probably to bits and then divide that by 32, and that would give you the number of ints that fit in there. So it could come as a um, word problem type thing like this, or I might just say, how many bits is 32 gigabits? Something like that. Um, Outside chance, if I'm looking for an extra question about, why we use a the different memory or the different number bases. Like, why do we use hexadecimal for memory addresses? Well, computers have lots of RAM, so there's lots of buckets of memory. And if we, so our computers are like a giant street. Instead of our complex human-like addresses, computer memory addresses are basically here's house one, house two, house three, so on and so forth. So we're going to have a lot of memory addresses in a computer with 32 gigs of RAM. Therefore, those numbers are going to get very large. And if we want to have them in a manageable size, we would maybe store that in hexadecimal instead of a zillion bits long memory address, even though they're the same value. All right, nothing about that. Nothing about that. This kind of deals with like the history of computers. This slide right here, 44, this is very related to our shortcut thing for binary to hexadecimal and hexadecimal to binary. Notice that the 4 bits of binary represents all 15 or all 16 unique hexadecimal values, 0 through F. So 0 through 9, then A through F. And that's why that trick works. Probably won't ask you about why octal, but you should be able to work with it in conversion stuff. Here's that slide. This is slide 47 that lets you review the conversion between bits and bytes. So if I give you something in gigabytes and I ask you to tell me how many kilobits that is, you would probably you would divide, well, actually, you would multiply by 8 to get you over here. And then you would start multiplying by 1024 to get you to your kilobits. So it's just moving back and forth between these two sides. 1 bit is 8 bytes, or what one, or sorry, 8 bits is 1 byte. 1 byte is 8 bits. A kilobyte is 1024 bytes, for example. All right, won't ask you about that. Won't ask you about that. Won't ask you. Won't ask you. All right, I won't ask you about any specific Python functions because the focus is going to be on the things we've done with Java since the midterm. You should certainly be able to write functions. I'm probably not going to ask you what's the definition of a function, but I would maybe ask you, write a function that does something, and you should be able to write the code to accomplish that. And also understand when I ask you to write a function, I'm expecting you to give me a return type, the name of the function, whatever inputs it takes, then the body of the function, the logic. I want a function is that. I'm not asking you to write the entire program where you have to do the whole main and all that stuff. I'm also not asking you just to write the 7 lines of code that solves the logic part of the problem. I want you to be able to apply generic inputs that come in as parameters to a function to the generic algorithm within the function. So definitely know what a function is and definitely know how to write them. Obviously, you should know what Boolean expressions are. I probably won't just ask you a straight up definition for it, but you're going to use them in your if statements and your loops. yada, yada, yada. I want to ask you about that. These are all things you will need, you know, assignment operators for creating variables and all that stuff. I probably won't ask any question that has you differentiate, what is nothingness in these different languages. In most of our modern compiled languages, it's null. Python, it was none. It's possible you might have to use that in your one of the functions or something, but it would be a very small part of it and probably not even necessary because it would just be the default value or something. All right. Okay, so now we're starting to get into some things that would be handy. So it would be fair game for me to ask you to write a function of some kind that has you use the index of function in Java, which is a member of it's a function that lives in the string class. So this takes in a char and returns the position within the calling string. So in this case, S, where that character was first found. So an E was found at position 1. The first place an L was found was at position 2, even though there's two L's. And if I'm looking for a question mark and the string does not have a question mark, it gives me a -1. And there's lots of little problem solving benefits to that index of function. So understand primitive type versus object types. Know what a compiler is. I don't know if I'll ask you it directly, but it would be fair game. Converts high level language like Java or Python. Well, in our case, Python's interpreted. So convert Java, C++, whatever, to a low-level language like assembly. That's all it does. It just converts between those two because ultimately our computers will feed off of assembly language that tells the CPUs what to do and gets converted into machine language at runtime. Understand that all programs begin and end with main. Know what I mean when I say that. Be able to work with strings. I've mentioned that Java is a string-based language, so being able to work with strings is going to be very handy. So be familiar with the functions like index of, like length, like char at, being able to access the individual elements of a string. I wouldn't ask you to, work with something abstract that we really haven't messed with strings or something out of the ordinary. So be able to put stuff in strings, be able to loop through strings, be able to access the individual elements of a string, be able to do concatenation with strings to build up strings. And also remember that strings are read only, so you can't modify a string in place. You can overwrite the string with things that have been added to it, but if you want to make changes to a string, you have to build a brand new string. That differentiates it from like a character array where you have a collection of chars just like a string is, but character arrays, each bucket is read and write. We can overwrite an individual bucket in a char array. Definitely understand the difference between printing something and returning something. That will almost definitely show up on the exam in the form of me asking you to write a function that I might specify this function should return some kind of value, or I might specify this function should display a value. Understand that there is a difference between those two things. Understand integer division. I probably won't ask you anything that makes you rely on it. I'm not looking to trick you on anything in the exam where something gets truncated when you weren't expecting it to. I'm looking for you to show me your current competence rolling into coding too. Also, remember, I mentioned this the first week of class, maybe probably the first day of class. As you work through coding 1, coding 2, and for some of you, coding 3, my expectations will also increase. So I have relatively low expectations of your coding competency off the cuff in coding 1. Every one of you should feel like, okay, you have a better shot at just sitting down and writing some code now than you did when you started coding one. But for many of you, that might still be kind of an uncomfortable thing where you kind of have to fight for it for a while. And I mean, you certainly should be able to write something. You should be able to write the nuts and bolts of a function. You should be able to make a pretty good shot at the logic inside the function, but I understand that there's going to be some syntax stuff in there and maybe some logic weakness in a coding one class. So, get yourself up to snuff, but um, know that I'm going to hold you to a different standard here than I will like on the coding two final. Uh, oh, let's see. When is the final and is it in class? Okay, that comes from someone who hasn't been attending class. All right. All right. So I'll put up the final on no later than first thing Monday morning. It'll be on Canvas. You need to turn it in by 11:59 p.m. on Friday. So whenever you find, I would set aside 2 hours to take the exam. I am going to design it to take about an hour, but I will give you 2 hours to do it. So it should not be a time crunch situation. But I'll have it up on Canvas by Monday morning. You have to just find a 2 hour slot sometime during the week to do it. It is closed book, closed note, closed computer outside of using Canvas. So I don't want you going and typing code in and testing it and stuff like that. I want to see what you're capable of using just your skills. You can use a calculator for conversion questions and that kind of stuff, but I don't want you running code that I might give you asking, what does this do? I want you to show me you can read that code. All right. Um, and Logan, you can still try to talk me into Godot, but you haven't even started trying to do that yet. You've just been, I don't know, doing your, hey, I'm afraid of Java crying stuff, which I do find entertaining. That's mainly the only reason I come to class. Nuh-uh. Ivy, it's going to be probably a combination of multiple choice, true, false, and then there will be a couple of questions that have you write specific code. So there'll be more like an essay type question. So be prepared for that for writing, let's say 2 to 3 functions, something along those lines. All right, did I hit all those that were in there? Okay, let's see. I guess I'll just leave the chat up over here. That way I won't miss. I got something new. You're going to use AI to try to convince me of Godot is the way to go? All right. Yeah. So in any case, be able to do common string stuff. You don't have to go and memorize the string class that we've looked at from the documentation. If I want you to use anything that isn't just super common, like length or char at, I'll tell you about it. I'll give it to you on the test. Um, Just a reminder, there's a little concatenation caveat between Java and Python in your favor. Java does not require both sides to be of string type. So in Java, as long as one of the 2 sides of the plus sign is a string, it'll treat the plus sign as concatenation, and anything after that will become a string. So that means that in Java, you can do something like that, and it will become the string for in that example. And that's very handy in a um, uh, language that works very easily with strings. So that's kind of a power move there in Java, even though it doesn't appear all that impressive in the moment. Sometimes little tiny things make a big difference when you go to write stuff. Yeah, so I did that on the very next slide there, it looks like. Here's that strings are read-only thing. Um, yeah, here's some just examples to stuff. You should be able to write a simple class. So kind of like we wrote fractions, where a fraction had two fields, a numerator and a denominator. A fraction had a constructor that built your numerator, that took in a numerator and denominator and set those two internal things. And then, it had some functions to do things with fractions. You should be able to create a simple class like that off the top of your head. If I said, hey, we're going to create a player has a name and a jersey number, write an appropriate constructor and a display method that shows that player or something like that, if I ask you to do that in Java. Let's see. I won't ask you about time complexity stuff. Well, it's possible I'll ask you about time complexity in that not everything runs super fast on computers. Sometimes there's problems like when we looked at fraction reduction, and then we looked at the Euclidean algorithm as like a mathy solution to that. I would say there's a low chance that I would ask you about um, time complexity type stuff, but that would be fair game. But you don't have to go and like memorize the Euclidean algorithm or anything. You don't have to worry about bitwise stuff. I probably won't ask you anything about XML or JSON on this test. We'll be working with that reasonably heavily in um, early on in coding 2. You should know what a base memory address is. This kind of comes down to how arrays work. Um, if I ask you what a base memory address is, you would say something along the lines of this is the memory address where a collection type begins in memory. So if you have a 10 bucket integer array, whatever the base address is, that would be bucket 0. And then bucket 1 would be a integer size step into memory off that base address. So this goes in line with what is contiguous memory. So that would also be fair game. Nothing about dictionaries. Definitely be able to work with classes. Know that classes are filled up with fields, constructors, and methods. Know what those guys are. Know that fields are the variables associated with a class. Constructors are our mechanism for building, instances of classes, and that methods are like the abilities the class has. You should understand why constructors do not have return types. That would be a fair question to ask. Be able to identify and create instances of classes, so know what an instance of a class actually is. Understand the this keyword, so the antithesis of self for Python. So the this keyword would be what I would refer to in this exam. So know that it's how an object refers to itself within itself. Be able to create random numbers in Java using the random class in r.nextInt. If you say random r equals new random, and then you say r.nextInt, understand that will give you a value in the range of all integers. So that's negative 2.1 billion to positive 2.1 billion. So if I ask you to generate a number between 1 and 10, you should be able to do that either using the alternative form of nextInt, which allows you to tell it a top level. So if you put in r.nextInt 10, it'll give you a value between 0 and 10. Actually, I think it's 0 and 9. The 10 is not inclusive. So if I say give me a value between 1 and 10, you can say r.nextInt, and then in parentheses put 10, and then after the closing parenthesis, just say plus 1. And that'll give you a value between 1 and 10 inclusive. So be able to work with random numbers. Nothing with big O notation. Understand pass by value versus pass by reference. and why we might pick one versus the other. Know what polymorphism is? Probably a low chance I would ask anything about it. Um, it's going to be one of those things where it would probably show up in a multiple choice question, and I think everybody would probably recognize polymorphism in a police lineup. So it probably would be just what you select. Um, I'm not going to ask about public-private protected on um, this exam. We will start using that properly in coding two. So it will be a
How many
topic in
questions
coding
will
two.
be on the exam?
1,000? Now, I'll probably do 10 questions, 10 points each. That's what I usually do. All right, so now we're getting into like our design for our dungeon. So again, be able to mess with classes. We see two different classes here, and we're kind of designing them. So we have a class with two fields, a name and a player. Actually, three fields. We also have a next room, and then we have a function called add player. So this is like examples of us creating classes that contain fields, constructors, and methods. Understand this concept that variables resolve to their most local definition. That would fall into that same category when you're working with constructors and your constructor takes in a variable called name, like string name, and you also have a field string name that we say, understand why we have to say this dot name equals name. And that's the appropriate way of doing things as opposed to arbitrarily giving yourself a different variable name so they're not confused. You should understand variable scope and how things resolve to their most local definition. And when you say this dot something, you're referring to the fields owned by this class bypassing local variable scope. Understand the concept of blocking code, so code that prevents the program from continuing on. This was our gateway drug to introducing threads. Be able to work with inheritance. And along those lines, understand the abstract keyword. Here's kind of like if you were going to have just a pocket answer to why do we have inheritance, we're trying to minimize the duplication of code. If you have two classes that both have a lot of the same, that both have all of the same abilities, and then one of the classes has a few additional things, that's the perfect setup for an inheritance model. So you're not writing those identical methods twice. I probably will not ask you anything about interfaces on the test. They're kind of a abstract-y and frankly not a good use of a question. So now we start getting into threads, mechanisms for overcoming blocking code. Um, there would be an outside chance I would ask you something about processes, kind of the predecessor to threads. Um, this would then require Logan to watch the video that he didn't watch. Let's see. I probably won't ask you CPU scheduling stuff. That would be um, um, more of an operating systems class thing. Threads will definitely be on there in one form or another. I would say there's a much better chance that thread will show up in kind of a multiple choice question. Um, Having you prove to me you understand the problem they're solving, something like that, because we really haven't had opportunities for you to mess with threads through programming at this point. We'll be using that a lot in early on in coding too. Okay, so that covers all the slides. What questions do you have for me, or is there um, uh, anything you want me to review before we continue on with our um, examples of
Can
threads and
you
starting
review
to
and
integrate?
compiled versus interpreted?
Sure. So, when you have two different languages, so for example, Python is an interpreted language and Java is a compiled language. Um, Interpreted means that the code is processed during runtime. So when you hit play or you tell your Python program to run, it is in real time converting your code from the high level code you wrote to something the CPU understands. So this would be akin to a real life example of you have a news report that was done in German, and then you have somebody who's um, uh, interpreting it and telling you what it says in English in real time. So they're listening to like the speech and then spitting out the English as they're hearing the German. So it's going to be there's going to be a delay, a little slowdown, something like that. Where compiled, what it does is before you ever run the program, it converts all your high level code, all your Java code into what's called bytecode, into low level code that is understandable by the uh, CPU on the computer. So this would be equivalent to in using that news report thing that we get the text of the German news report ahead of time, and then somebody's able to translate it into English ahead of time, and then when they actually go to give the report, they already have the English version of it ready to start delivering it. So there isn't that delay. Does that make sense?
Yes.
All right. What other things should I? Oh, I see all these sixes and sevens thing. Isn't that this newfangled thing? I'm guessing, did something just get recorded that has a meaning that I don't know what it means that it probably shouldn't have said on recording?
Can you go back to blocking code?
Blocking code, yeah. Um, well, here, let's just come here. So blocking code would be when you have a line of code that pauses. So the best example for us is when we have our prompt in our game say, "Hey, user, what would you like to do?" And then it's sitting there waiting for us to type in something. And we don't know if the user is going to type in something in 2 seconds or in 20 minutes or ever. So that code blocks the rest of your program from running. um, it blocks the rest of your program from running. So if we want to be able to overcome that, if we want to have things in our program that still are able to do stuff while we're waiting for input from the user, that's when we need to bring in something like a thread to be able to go off and do its own thing while this blocking code is sitting there in this example waiting for the user to type something. So that could be waiting for user input. That could be something where you have a function that just takes a really long time to run. Let's say you have a function that's, trying to reduce a fraction and it didn't use the Euclidean algorithm and it's going to take 4.5 hours to run. Well, that would certainly block the rest of your program from making any additional headway. So you would need to have ways of getting past that or just accept that my program is going to be sitting here for a while. I should go to sleep. That makes
Also,
sense?
do you think you can go over primitive types versus object data types?
Sure. So I mean, they both are built, so they're both variables. All right. So when we talk about the big picture of variables, these are a named bucket that can hold a value that we might want to access later on. So, well, they're related to variables. I don't want to say misleading stuff. So we can have variables that are capable of holding either of those. We can have variables that can hold primitive types like integers. We can have variables that can hold object types like strings. Now, the primitive types and the object types themselves, though, dictate what kinds of things they can do. A primitive type can only represent a single value. So ints can only hold numbers like 32 or 47 or -5. They can't do anything additional. They can't, take the square root of themselves, for example. All they can do is hold a value. Whereas object types can potentially hold a value. In fact, they don't even have to, although usually we'll have an object type with at least one field. But so they could hold one or more values. I guess technically it's zero or more values, but they can also potentially do other things. They can have multiple ways of creating them through multiple constructors. They can have multiple abilities, like we can ask them to display themselves. We can ask a fraction object to reduce itself. We can ask a string to convert itself to uppercase or to lowercase or that kind of stuff. That makes sense? Let's see, what
You're
am I?
basically saying that like object types have more like flexibility and they can do multiple things.
Yeah, I mean, flexibility is it just depends on what you're trying to accomplish, but an object can just do more. An object is like a Swiss Army knife where, that has a whole bunch of stuff built into it potentially. And a primitive type only has a single blade for cutting, something like that. That's probably at least a decent metaphor. Isn't that the guy from Clash Royale? That's what that means? Well, I guess I still don't know what it means, but the sixes and sevens thing is, I see it on there. So I guess it can't be that
But
bad.
you would say like a string is an object type because you can do multiple things.
Correct. Yeah, strings have a bunch of methods built into them, therefore it's an object. Even though that's sort of a wonky example in Java, since technically strings are objects, but in Java they behave like primitives in terms of how they're passed around. Strings are passed by value, just like primitive types are, where all the other objects are passed by address. But your statement was correct. Objects can potentially do a whole bunch of stuff. Primitive types can never do more than one thing. All they can do is hold a value.
I'm going to get all of my money's worth in this Zoom meeting, so I don't have to
That's
struggle too
fine.
much by myself. So that's why
No
I'm
worries.
asking all these questions. So can you also just go over like the this keyword again, and other than like how to use it, of course, just like why we use it?
Okay, well, so the this keyword, that's how an object refers to itself from within itself. So the idea here is when we first create an instance of an object, and I can go here, we can see it probably here. So let's say that I come out here and I say player P1 is equal to a new player. And I think this guy probably just took a name of a player. All right. So if I want to work with this player out here, I can always call him by his this local variable name P1. Variables resolve to their most local definition. So if I say P1 something here, it's going to resolve to this variable right here. All right. Now let me just review real quick what's in player. Player has a display function. Okay. So we'll go back out here to driver and we're going to go ahead. We're going to say P1 dot display. All right. So we create it right here. We want to call that particular instance of players display method. So we say P1.display. That then is going to take us into the player class and go to this display method right here. So why is this keyword needed? It's because we can't do that. We know in this particular example that we used P1 to call this display function, but we used P1 out in the driver class. Right now, we're inside the player class. P1 is not in our scope. We can't access P1, but we do want to talk about P1's name in this example. So instead of P1, we would say this. This is how an object refers to itself from within itself. So if I were to print out this, the value of this, and I were to print out the value of P1, they would hold the exact same memory address.
So it's basically like you're trying to call like an attribute of a class within itself.
Well, I mean, no, it's more pointed than that. Inside of a class, we don't have access to the external variable that was used to call a particular function. So if I want to talk about stuff that's owned by this class, the only way I can talk about myself, if I'm the instance of the class, is by referring to myself as this. I don't have any other way of talking about my fields. I can't get to them if I have a local variable. So if I had a local variable here, string name is equal to LOL or something like that. If I actually
Wait, so
want
you're
to,
saying if we were to call something within our specific class, like we did, like we created an object, the player object, and we wanted to get our name, we would use the this keyword to access that
only
because we're
inside the
basically
class.
calling
Only,
P1 from a different class.
oh, yeah, only inside the class. I mean, we brought this player into existence out here. So he came into existence here inside of driver. Well, inside of main, which lives inside of driver. Well, P1 is a player. Therefore, we are asking this particular player to call his display method. Well, that takes us to an entirely different planet. We leave the driver class and now we come into the player class here. P1 does not exist on this planet. We can't access it on this planet. So if I'm in the display function, for example, if I just have the code written like this, technically we do not have to use the this keyword here. Why? Because all variables resolve to their most local definition. The most local definition of name right here, well, we look locally first. Is there a definition of name here? There is not. So we bounce back up. We look and see that, oh, is there a definition of name here? No, there's not. Well, are we done looking? Technically not, because a player inherits from entity. So we go up to entity. Is there a definition for name here? Yes, there is. So if I were to say just name here in display, it would find the correct name. But good programming practice and to give yourself faster code, because understand what we just did. We said, let's check place number one. We didn't find it. Let's check place number two. We didn't find it. Let's check place number three. We finally found it. So we actually had to look in three different places before we finally got to our found our name. Whereas if we just said this dot name here, it would directly get us to that place. Now, it would actually be required in this case, because in this case, if I didn't use this dot, again, all variables resolve to the most local definition. So name, even if we meant the one owned by the player, which came from the entity class, if I say name right here, it's going to resolve to its most local definition, which is this guy right here. So it's going to print out LOL, which is probably not what we want. So if we want to be specific and we want to talk about this particular instance of players name field, we would say this dot name. This is how this particular instance of the player class talks about himself from within himself because it's on a different planet than we were on out here when we had access to a variable called P1. That make sense?
Yes.
And also keep in mind that you're probably asking questions that other people in class are also asking in their head. They just don't talk. Oh, my default. Oh, it just said my internet connection is unstable. Whatever. Everybody
Can
can
you
still.
control the tomfoolery in the chat?
What's happening in chat? I don't see it anymore.
Can you control the tomfoolery in this chat?
Are they getting out of hand? Think we can.
It's a war zone in here. Take away all their rights, specifically Nolan.
Is that even possible? Do I want this on the recording? Like as I'm scrolling through here? Well, I see a whole bunch. This is all Clash Royale
No,
stuff.
it's not even that bad, but I think it'd be even better if we took away Nolan's rights to chat.
Oh yeah. Read his essay. He sent you an essay, Dr.
Oh,
Lippman,
about the Nolan did or Logan?
about Godot. Logan, about Godot. Bro put minimal effort into it.
So who
Not
is
even
Messi?
changing the
Isn't
ins.
Messi a soccer player? Who is Messi? Oh, that's you.
It's me. It's me.
Well, hold on. You usually attend
Don't.
class, and you asked when the exam was.
I forgot. I missed the day you went over it because I was in Florida. I missed Monday and then I forgot because I was so
One
cooked.
job.
I was sick all of break. I was cooked. I forgot a lot of stuff.
Okay, you were
Should
sick
have told me
over
to bring
break
some.
in Florida. We're all feeling sorry for yourself, for you. What part of Florida?
Like Tampa area.
Oh, okay. Well, west coast of Florida is not all that amazing weather. Plus, they have a terrible cruise port. They don't even open the
I
casino
have to.
until the cruises left the port for like 2.5 hours before they finally open the casino because of Tampa Bay is the
My
size of a
essay.
continent. All right. What other questions do we have? Well, I'm gonna
Another
read.
question I have.
All right, go ahead. We'll
Uh,
read Logan's essay at the end when we're out of questions. Keep going.
no, no, please do. Please read Nolan's essay. I mean, what's his name? Logan. He's gonna lose his mind. Please do.
Well, is it
I mean
good?
the
Is
AI's
it
essay.
is it recording
Well,
appropriate? I mean, it's one thing if it's in chat, but
yeah.
if
It
I
is
say it out,
so AI. I'm sorry. This is a graciously AI. I
He
would
didn't
all right,
even.
fail
hold
every
on.
class if I
Actually,
did
to
this.
give Logan a little bit of credit, it was pretty funny. He sent me a message the
He
other
didn't even.
day letting me know he wasn't going to be in class. He was going to travel home for break early. And he purposely wrote the email in like the most chat GPT way possible, like leaving the square brackets in, like insert
Oh
professor
my.
name here. And so that was pretty funny.
Here's an
Extra
essay
credit.
that let your professor know you won't be in class.
It
Well,
even has the emoji on it too.
it wasn't even a long email. It was just completely, template. It was an AI template email
Oh,
that he didn't fill in any of the templates.
Literally, just take a look at the first sentence.
that's
Here's
the
a
same thing with
polished,
the essay.
persuasive pitch you can send to your professor,
Yeah, I get
framed
it.
from an educational perspective. That is bad.
It was
Well,
inspiring.
are you going
I
to
read
keep
the whole
reading it?
thing.
You were doing such a good
Oh,
job
I
reading
can I
it.
can read it for the I'll read it for the
Read,
masses.
Okay.
read,
I'll read it for
child.
the method. Okay. Here's a polished, persuasive pitch you can send to your professor, framed from an educational perspective rather than a student preference. Subject: proposal to consider. What is it? Godot?
Godot. I think it's all Godot.
Godot,
Godot.
Godot.
Godot,
Godot.
Godot engine for course. Use hello
Godot.
professor in brackets name. I wanted to share suggestions for future game development coursework. Adopting Godot engine instead of or alongside Unity. There are several academic and practical advantages that I believe align well with our program goals. App emoji. Why Godot benefits students? One, open source and free forever. Godot is fully open source under the MIT license. There are no subscription fees, license changes, or revenue based restrictions. Students can continue using the same exact tools after graduation with no financial burden. Mm.
Can I pause
Two,
there for a second?
transparency.
Let me pause just
Go
so I can
forth.
answer to that. So what that will translate into, Logan, is a product that as soon as the developers lose steam working on it because they're not making any money, it's going to stop evolving. Unity is free for students. I understand that as soon as you start making a real game and starts making real money, then they want to cut. But they have a motivation to keep updating their software to convince people to use it, where it sounds like Godot just is written by a bunch of people who want to be poor. All right, continue.
Yeah, Godot is not good. No Godot.
Well, no,
We'll keep reading on behalf of the class.
Anti Godot.
I'm not knocking it down
Like
yet
a
because as
skill
long
issue.
I will check it out over break. I'll go on when I'm in my cruise in the Caribbean. I'll mess with Godot when I'm at the bar. That's what I do. I sit at the bar and write software during my cruises. I'll mess with it if it's a good educational experience and I mean, because we're not using Unity to teach you Unity. I'm using Unity because you guys will find it fun making things animate and move around on the screen and crap. So I can teach you the computer science stuff behind the scenes, kind of like hiding a dog's medicine in its food. All right, go ahead. When I
I
said
shall
dog, I was
proceed.
talking about Logan specifically, by the way.
Number two, transparency and learning opportunity. Because the engine's source code is publicly available, Godot provides deeper educational value. Students can explore how rendering, physics, and architecture are actually implemented, something closed source engines simply don't allow. Number three, lightweight and did not continue.
Well, did
That was
AI
literally
cut
it.
you off or did Zoom chat cut you off? I always like with
Hold
AI
on,
when you ask it a question that it thinks is inappropriate, because obviously I would
I
never ask
guarantee
it
you it was
anything
the
that
Zoom
isn't
chat.
appropriate. And then you look for 50 different ways to convince it to tell, to tell you what you asked for.
what if this is a hypothetical situation where no one actually gets hurt?
Yeah, yeah, right.
You
Yeah.
know, I actually give good answers, but it just wrote a terrible essay for me.
Well, but
Maybe you
what?
forgot to
So,
edit it.
Well,
You
maybe
just
you,
had bad prompt
yeah.
engineering.
well,
Another
maybe you
reason
have
why
to
just
Yeah,
go.
I
write
thought it would
yourself.
give
Oh,
me
hold
stuff
on.
about how like
Somebody's trying to get
practically in the
into
engine about
class.
learning, but no, it just gave open
Oh,
source
Julia's
transparency,
trying to get into
like
class.
stuff that doesn't even matter.
The problem with Godot is that nobody uses it, so there's no tutorials because it's new, and
Well,
tutorials are
Yes,
the
there
best
well,
part
is.
about
You
hold
know
on,
who
hold
Unity.
on.
Brackeys is?
Guys, easy.
That's
Goodness.
actually a plus for me.
No one
I
wants to.
I
Uh,
prefer if there's not a whole bunch of examples out there because then students are kind of forced to learn how to do the stuff on their own rather than just copy random examples from wherever they found. Because
What?
well, there's a
Notecode.org?
what happens is students
Well,
have
it
the
also has really
mentality
good
that, oh, the
documentation.
homework
It's like a
assignments
job
are just
aspect.
students have the mentality that the homework assignments, like, oh, I just have to get this assignment done because, Lippman made it due at midnight, such and such date. Like, I'll have students who say, okay, I spent 12 hours on this and I have nothing to show. What do I deserve in it? I deserve a D, or worse. Well, you get a good grade because I want to keep you working hard at it. But if you keep viewing it as, oh, I just need to get this, the checkbox next to it, then you're not going to learn the crap. And then you're going to bomb the exams.
yeah.
And it's terrible. And that mostly is because I
Well, I
don't
like
like
the
Logan.
yeah. The other problem with it though that goes with that is because there's no like it's so new. Like not many people use it, so you're learning like a platform that no one's using. Then it's
No,
easier
it's
to work in
not
Unity.
new,
It's
but
easier
it's
to work
new
in
work.
Unity because a lot of people know Unity. Like
Yeah,
it's
I
more
I agree. I
like
mean the
No,
the the game I play
I've
D and
used
D with
Unity and
students.
Godot. I think Godot is
Yeah.
easier to use. I've
like
used
Unity's
both of
more
them.
established and has a better reputation. Well, not a better reputation, but it's
Yeah,
more
the reputation is
established.
screwing over its users.
It's more established.
Well, hold on.
Everyone knows, like most
How is
people
it
know
screwing
it's
over its
How
users?
about how about we answer all 16 of my questions so that way we can all
Oh, we
we can
got more
all calm
questions?
down.
16 questions.
We got more
What,
questions?
I don't know how many questions it is.
All
brother?
right. All right. So let's table this Godot thing and move it offline. But I mean
It is better.
I'm just saying that
I
the game I
concur.
play, the D&D game I play online with students and faculty, we play Demio. Their brand new game that just came out 2 weeks ago, was written in Unity, and was fully funded by Oculus. So they got, probably several $1 million to write a video game that was released on the Steam store and then also on the Quest, and it was written in Unity 2 weeks ago. That sounds like a skill that maybe students could use to make some money if they come up with a cool idea when they're in school. And then possibly put out in the App Store without letting Unity know about it and maybe get away with something for a bit. I'm not recommending that, but,
So it makes
and actually, I think that if you put the Unity splash screen on it, their revenue sharing thing is significantly different. Either they don't share it at all or they take a much smaller cut. If you want to have your own splash screen, I think then they get a bigger share. All right. But anyways, go
No, I
ahead.
think the Unity splash screen is required.
Oh, I'm sure if you pay top dollar to Unity, it's not required. All right, go ahead, coffee. Next question. You're
Thank
muted.
you. All this tomfoolery. Okay.
Nobody's
Can you explain what you mean when you say all programs begin and end with main?
right here.
Wait, I can't see. Hold on. Ah, yes.
My program starts with driver. Can you see it now? All right, so out of all of
Yes.
these classes we have up here, I have a class called driver, I have a class called dice, room, player, dungeon, entity, NPC, worker bee. Only one of these files has a main method in it. That is the file that we intend to run when we run our program. So doesn't matter which of these things I'm on. If I hit run, it will run the main method in driver. Usually you want to be on the tab that you're going to run, but only one of these classes has a main, and it's right here. So when I run this program, it begins right here in main, and it ends right here at the end of main. Now, during that voyage, it might jump into the player class here. It might jump into the worker bee class here and do some stuff. But ultimately, it always comes back home here to main and finally ends right here. So all programs begin and end with main. And that's true in every programming language. Python makes it difficult to see, but we did see it when we looked at Python. Most languages have a specific main method like this. They might have some small little deviations, but they'll always be a main method.
Also, can you go over what a base memory address is?
Base memory addresses, I'll actually do this with the slides. I think I have an array picture flippy dealy thing. So when we use the new keyword, specifically with arrays, is this, didn't I draw pictures somewhere? I had to have drawn pictures somewhere. Well, whatever. Well, here, I'll do it this way. So if I do something like, click, double click, triple, quadruple, int array AR is equal to a new int array 3, for example. Now, the new keyword, this guy's our real estate agent, right? It's going to go get us a memory address. So let's just assume for a second that it went out and it got the memory address 100. All right. So that means AR, this variable right here, ultimately got the value 100, which is the memory address that was returned when we asked it to build for us an array capable of holding 3 integers. So that means out here in memory somewhere, there are 3 buckets right next to each other. This is called contiguous memory. So contiguous memory is memory right next to each other. And what we have is for AR, it points to the beginning of this array. So I'm going to do a couple of different things here. So we're going to say this is bucket 0, this is bucket 1, this is bucket 2. And then we're going to say this is memory address 100, this is memory address 104, this is memory address 108. AR holds the number 100, which is the base memory address of this array. That is, it is the place where this array begins in memory, right here. Now, when we build an array like this, it doesn't actually have values in it yet. It just has empty buckets capable of holding things. But these guys live in contiguous memory. The base address here is 100, which is also bucket 0. So if we were looking at this in a language like C++, we would say that AR at bucket 0 is equal to AR plus 0 times the size of an integer, which is 32 bits or 4 bytes. So this will be 100 plus 0, which is 100. Bucket 0 lives at memory address 100. Now,
Is the only reason why it's at 100 because we set AR to 100?
I didn't. I pretended like I was the new keyword. And I went out and talked to the operating system, and I came back with the operating system told me that it has a nice piece of land available for me at memory address 100. I just made it an easy number for us to work with instead of like a AE23 F uh, BBC or something like that. That's a much less friendly number for our example, right? So I made it up. I pretended like the operating system said that we got memory address 100. So AR at bucket 1 using the same math would be AR plus 1 times 4, which is 100 plus 4. 1 times 4 is 4, which is 104. And that is the memory address where bucket 1 of AR lives. Bucket
So
2,
like the base memory would technically be like
beginning.
where, well, the base memory would be like the plot of land that we have that we're like given or started on with.
Yeah, where we started with. And when we're working with arrays, arrays require contiguous memory, which means memory right next to each other. I've asked for 3 integers. So one of them is at the base address 100. The next one is the next integer sized chunk over, which is memory address 104. And the next one is the next integer sized chunk over, which is memory address 108. So just to finish this up, this is 2 times 4, which is equal to 100 plus 8, which is 108.
Will you ever require us to memorize that like little formula that you had right there?
Well, I mean, I'm not going to ask it on a test because this would be stuff that you'd see. This is happening behind the scenes in um, a language like Java, really in all languages. You know, we use arrays like this. We say AR at bucket 0 or AR at bucket 2. We don't think about the memory address that's behind the scenes. As computer scientists, we want to understand that there's this memory that's behind the scenes. We want to understand that arrays are in contiguous memory. That is something that's going to be very talked about when you get to coding 3 and you start looking at linked linear and nonlinear linked data structures because those guys are not in contiguous memory. Typically, arrays are less memory efficient, but they're fast. And linear and nonlinear linked data structures are much more memory efficient because they are laid out all throughout memory and only expand or contract as you need them to. Yet they are slower because you have to traverse through memory in order to get to bucket 5. You know, to get to bucket 5, you start off at bucket 0, you ask him, where's my next place? Then you go to bucket 1. Where's my next place? You go to bucket 2. Pretty similar to how we have our rooms. Our rooms are effectively um, linear linked data. Well, I guess it would be non-linear linked data structures, you know, because now they go to multiple potential places. So you wouldn't have to memorize this to show me, but as a computer scientist, you should kind of understand this is what's happening behind the hood with an array, with a base address of something, with the knowledge that arrays are stored in contiguous memory. But a base address is where does an object or an array start in memory? because objects work very similarly to this. They're laid out like arrays.
Okay.
All right, next question.
The next question. Okay, this is probably my last one because I know people are coming in. Could you explain pass by value and pass by reference one more time?
Sure. So this refers to when we're calling a function. So when we have a function and we are passing it a value, so if we have a function that takes in an integer as a parameter. So let's say it's p1 dot add num or something like that, and we pass in a 2 there. This 2, which is a primitive type, would be passed in by value, which means we get a copy of that passed into it. Where if any changes we make to it inside of the function will not be felt elsewhere. Yet, if we have p1 dot change stuff, and we pass in a new, well, actually, let's just say will pass in one of our worker bees. We'll just pretend like we have a variable called WB1 that we had created up here. WB1 is an instance of an object. It holds a memory address. Well, when we pass it in to change stuff, it's not going to send in a copy of that object. Instead, it's going to send in the memory address where that object actually lives in memory. That's passed by address. So anything we change in that object inside of that change stuff method here will be permanently felt anywhere that is trying to access the WB1 object. So pass by address is
You
when we're
said
passing
anywhere
it.
we change.
Well, if we change it inside of change stuff. Basically, pass by address says, I'm giving you the real thing. This is the one of a kind thing. Anything you do to this, everybody else will notice. You paint my, I think I used in class the example of if I give you the address to my house and you go and paint my garage, I'm going to notice my garage has been painted when I got home because you changed the original. Yet, if I give you a copy of something, like if I give you a copy of a quarter and you go and melt the quarter down, it's not going to impact the other quarter that I made the copy from that's still in my pocket. So pass by value, you get your own version, your own copy of it. You do what you want to do with it. Pass by address, you got to be careful because you don't want to leave it busted for whoever comes to use it next. But in Java, we don't have explicit ways of determining that, whether it's passed by value or passed by address. They make the right choice for us. So all objects are passed by address, all arrays are passed by address, all primitive types like integers and chars are passed by value. Strings are also passed by value. So strings are the
And the
one
only way that like those
alternative.
changes are made, right, is if we change WB1 or if we change
If you
like the
do
method
something
change stuff.
inside of this function.
Okay.
Yeah. The difference is if you're passing by address, you're giving it access to the real thing, the original. So user beware, be careful with changes. If you're
So,
giving it
so
a
those changes
primitive
would be
type, you're giving it
permanent
a
though to
copy. They would be
WB1.
permanent. Correct. They'd be permanent.
Okay. Thank you very much. And forgive me for like talking over you. I just low key didn't want to lose my questions.
Oh
I'd be
no, it's
sad.
fine. It's all good. All right, so are we good? Man, there's so many
Yeah,
sixes.
you guys can be free until what's his name decides to
Yeah,
send you another chat GPT prompt.
You probably
we are
will.
good.
Logan. Yeah, Logan.
Sounds like a skill issue.
What is this?
Now,
I'm pretty sure I know what it is, and I'm not
it's
going to say it out loud. All right.
it's new. It's new. It's a baby.
Oh, I see. All right. Well, there's probably another class
I don't
coming
know.
in
It's from
right now.
TikTok.
So- all right. Well, so anybody who wants to start playing Dungeons and Dragons with us, get the new Demio game, Demio Dungeons and Dragons Battle Marked, and we play like 5 or 6 days a week in the evening.
How much does it cost?
I don't know, probably $40 or $50 on Steam. The Steam version
Yo,
supports
5 Nights at Freddy.
the Steam version supports both VR and just normal PC. Most of us play in VR, but Blade plays on PC because he gets motion sickness and nothing worse than a Chinese guy screaming because he's gonna puke.
Hey, just
All
so y'all
right.
know, Five Nights at Freddy's 2 comes out tomorrow. Be
Yeah.
ready. I will be attending day one.
What's the game that comes out?
It's a movie, Five Nights at Freddy's 2,
Yeah, yeah,
the
yeah.
second one. Yeah. I have to go watch it.
Okay, so you're excited.
Brady,
I
you
thought
gotta
the
study for
Yeah.
exams.
I thought the
Nope.
first one was overrated, like heavily overrated.
What?
Yes.
What? It
What
was
did you
great.
think? What did you think was so great about it?
It didn't take itself too seriously. It, it wasn't scary, no, but it was kind of funny. Like it was ironic in a sense.
Yeah, but isn't FNAF supposed to be scary?
Well,
Isn't it a
this one's supposed to be more scary, so it's gonna be good.
Carson? No, no jump scare.
I'm